Hello everyone, and I would like to tell you today a story about natural language processing, especially or specifically about one of its super important areas, which is text analysis. But first of all, I'd like to ask you a simple question. How many of you have been working so far with some things related to machine learning? Please raise your hands. Okay, quite a lot. And how many of you have worked with natural language processing? Not so many, so probably you'll learn something from today's presentation. And this is quite a convenient situation for me because I can tell stupid things and probably nobody will get it. Okay, so let's start with a short agenda for today. I'll draw a picture about what natural language processing is. I will tell you something about the text analysis techniques. I will tell you how it can be used in business. But also I will show you some code, so how to do it. I will not only tell you what you can do, but also how. Okay, so what NLP is exactly? There are a lot of pictures telling you the story about NLP, what NLP is, what it consists of. I like this picture mostly because NLP is quite a large area of subjects. Different things come into this wide topic. But the three main areas are, first of all, is natural language understanding. So first of all, we have to understand what is written. Then there is a quite important and modern area connected with natural language generation. And we have also an area connected with dialogue management. You meet that all the time with chatbots or these kind of things. But of course, natural language processing is not only these three things, but also a lot of techniques that you can merge together, that you can use together in your applications, in whatever you want to have. And my first thought is that I want you to end this presentation with one general idea. That natural language processing in its deep areas is very complex. It's super complex to create your own models because you have to have large data sets, you have to create super complex models under the hood. But basically, when you use it, it's the same story as you are using, for instance, payment gateways in your applications. You actually don't think about how it works under the hood. You are just using it because they have an API, they have some flow, and you're just using it. It's the same with NLP. You can, of course, create some very sophisticated models. You can create very sophisticated applications with NLP. But on the other side of the coin, there are a lot of applications and a lot of methods that you can use just simply consuming some APIs or some internal libraries. I will cover that in a minute. But first of all, what is NLP exactly? I like to look at NLP from the context of tasks. So we can use it for different purposes. First of all, we have text and speech processing. So you have, for instance, OCR, you have a lot of text-to-speech or speech-to-text systems. They are very sophisticated. Usually you consume them as an API. Then we have something on the, let's say, on the other side of the X. So you have a morphological and syntactic analysis. So you have to tokenize your text, so divide it into words. Let's simplify this concept like that. Then you have lemmatization and stemming, so finding the root forms of a word, like for instance the word closing. The root form of the word is close, or the word is, the root form is be. Then you have morphological analysis. So first of all, you have a word, but you would like to know what form of the word you are dealing with. Is it, let's say, singular or plural? Is it tense? What tense does it have? Is it past, present, or future, or these kind of things? Then you have a part of speech tagging, which means that you find a way how to define, how to identify the role of a word in a speech. Is it a verb? Is it noun? Is it adjective? Then you have syntactic parsing, something a little bit more complex because it detects the dependencies between words. For instance, if you have something like best conference, then best is actually describing the conference. So this is a role of, this is what syntactic parsing can do. Then you have something layer up. So you have a lexical and semantical analysis. So first of all, you can find named entities. So countries, states, brands, organizations' names, different things that are named entities, or like your name. So you have also something that is very popular, which is the sentiment analysis. I will cover that later in details, and semantical analysis. For instance, when you define that this word, like for instance, pizza is a food. Then you go even more to detect or to identify the relations in the text itself. So it's not on the level of sentence, but it's on the level of the whole text. For instance, you can have coreference resolution. This is quite an interesting thing. If you have a sentence saying, for instance, Billy is in New York, and the next sentence says, he is very satisfied, then it means that he relies to or reflects to Billy. So to detect that, you use the technique called coreference resolution. Then you can have something more sophisticated, like a relationship extraction. If you get a whole text about the family, then you would like to get the information who is uncle to whom, or who is father to whom, and these kind of things can be provided by relationship extraction. Then there are some other things like textual entailment. This means that if you have two sentences, one can be sourced in the previous one, and you have to detect if the reason of a given statement was mentioned before. Topic modeling is something that I will show you in details. Argument mining is even more complex when you drag the arguments of a given statement in the text. So there are a lot of other techniques that allow you to analyze the whole text and get the real information out of it. Then you have some high-level tasks, high-level things for NLP. First of all, on the left-hand side, you have something which is called dialogue management, which I mentioned before. It's connected with chatbots. It's connected also with the question answering tools, these kind of super complex things. And some tools that you probably use every day, sometimes without even knowing that. So like machine translation, all of us use it. Grammatical error correction, you have it in any text editor. You have some other tools for that. You have something like text generation. I don't know if you heard about GPT-3. This is a very complex model allowing you to generate text. It was even an experiment taken where GPT-3 was able to generate an article, scientific article, that was approved by a commission, that it's a valid article, and this is unique in its knowledge. So basically, this is very complex and very interesting. And text summarization, I will cover that later. So let's focus on some NLP techniques. And please consider one thing. NLP, as I said, is super complex under the hood. But what you have to do to use it efficiently is to understand these concepts, these techniques that will allow you to use it just as a simple library implemented or included inside your software. First of all, you have named entity recognition. So it allows you to find the entities in your text, like here below you have an example. Code Europe is the best conference for developers in Poland. So you have two entities found, Code Europe and Poland. You don't have to write anything about that. It's just a simple line of code. I will show you that later. This approach to named entities is one of the most important ones because the thing is that whenever you find the entities in your text, then you can analyze the whole text with the context of these entities. Suppose you have a long text where you have a lot of brands mentioned, and you would like to check what these brands actually, what do people think about these brands? What is super important? What is important for these brands? Then you can divide the text into sentences. You can find these entities and analyze only particular sentences from the whole text. Next technique is called part of speech tagging. You have an example on the right-hand side here. So you have a part of the sentence that I mentioned before, which is Code Europe is the best conference. You have it's divided into tokens, and these tokens are lemmatized. So as you can see on the left-hand side, you have the word is, and the lemma is B. So this is the root form of this token, or the text is best, and the lemma is good. But then you have two columns. One is a part of speech, and the second one is tag. These are the shortcuts used in the library that I'm using quite often, which is called Spacey. And these shortcuts mean something, always mean something, and you can get the list of the meaning. For instance, the first propen means proper name. Then you have some determiners, adjectives, nouns. The tag means something more specific for the given word. For instance, VBZ tag means that this is a present tense, third person, and I think that it also defines the mood. But this can be easily decrypted when you deal with part of speech. This gives you even more information, because probably when you analyze text and you want to find what people think about something, then you probably have to remove all the verbs, all the determiners, and all the things that do not have any meaningful value for your analysis. Then you have something that is called morphological analysis. This is an example of the same sentence, and the morphology can be found easily. And you see on the right-hand side that the morphology of the word Code Europe is number is singular. For is, that the mood is indefinite. The number is singular, person 3, tense present, and all of this information can be dragged out of these words. And you probably might be interested in, for instance, in all the sentences that relate to the past, not to the present tense. So you might easily look for all the sentences that have the verbs mentioned in the past tense, for instance. Then you have syntactic parsing. This is something that I mentioned before, which is quite interesting, because then you have to, you are able to find the relations between words. Because suppose that you have a sentence that says something like below. So again, Code Europe is the best conference for developers in Poland. But this sentence might mean something different. For instance, someone says, Code Europe is the conference for the best developers in Poland. So you have to know exactly to which word does the word actually relate. What is the meaning of this? Is this conference best or developers best? So then you can use the syntactic parsing analysis to detect these relations. I don't know if you remember, but most of you probably did these kind of things at school. In your lessons of, I don't know how many of you are not Polish, but in Polish schools, most of the times in, I don't know, it's third class of a grant school or something like that, we do such things. And this is something that comes out from the automatic library that does it for us. If we've had it at school, well, the life would be even simpler. Then we have something that is called semantical parsing or semantic parsing, when we find the relations between words, because we know that they mean actually something which is similar in meaning. For instance, I have an example later on with restaurant reviews, and you would like to detect all the sentences that speak about food. Then semantic analysis can help us to find these sentences, can help us to identify the sentences where food is mentioned. You don't have to actually care if it's about chicken, pasta, food, pasta, pizza, or something like that, but with semantic analysis, you are able to detect which sentences are actually speaking about food. Sentiment analysis, this is something that probably most of you have met before. This is the output of sentiment analysis for the sentence that I mentioned before. So you can see that the polarity or sentiment is 1. There are 2 basic definitions of it. Sentiment might be positive, negative, or neutral, and sometimes it's mixed, because if you have longer sentences, they might be divided into 2 parts. One is positive, the second one is negative, and then the sentiment analysis will tell you that the sentiment of the sentence as a whole is mixed. But basically, we can say it's positive, negative, or neutral. But polarity will give us a little bit more information, because polarity is a variable which takes values from -1 to +1. Well, +1 is totally positive, -1 is totally negative. And you can, because it's a difference if you have a sentence that is 0.5 polarity and 1 polarity, it makes a huge difference sometimes, of course. But the library that I'm using, so I mentioned that before, is called Spacey, provides also additional information, which is subjectivity. So it means how much subjective this given sentence is. And it also provides the layer of assessment. So it gives us an information why this sentence is considered being positive. And here we have to be very careful, because the sentiment analysis is done in, it might be done in different ways. For instance, there is Amazon has a API service, or a service which is called Amazon Comprehend, that delivers the same information, but it's much smarter than the Spacey. The thing is that Spacey is based on a dictionary. So whenever it meets something like best or good or something like that, it will consider it positive. But there are some sentences that are certainly positive, but will be considered as negative for Spacey. For instance, there is an example of these restaurant reviews when I looked at that, and there was a review saying you won't be disappointed. Spacey will say it's negative because it's the word disappointed inside. But Amazon Comprehend will give you better information that it's positive, because it is positive, in fact. So you have to be careful and use the tool that is relevant for your needs. Text summarization is something super important for executives, for any additional analysis, because if you have a long text, you don't have time to read it, or you have a bunch of texts or a bunch of reviews, so we can use text summarization, which is quite complex to implement. It's not provided by default by Spacey, but it might be used in a not very complex way. You don't have to know the neural networks and anything like that from a machine learning perspective, but you have to efficiently use the libraries that can do text summarization for you. And one more. Topic modeling. This is super important. In every text analysis, topic modeling is present. Topic modeling is, let's say, basically an unsupervised learning mechanism, which means that it just takes the text, divides it into sentences, and assigns a topic to every sentence. But these topics are abstract. It's unsupervised, so we don't have basically any reference. We don't know what does it mean that it's topic number 6. You can have a text that you divide into any number of topics, like 20, and you don't know what they mean. You have to do it yourself. There are methods called anchoring, where you say that I want to have 4 topics. One of them is for pricing, one of them is for, let's say, quality of service, one of them is for quality of food, and the others for cleanliness. So you probably might assign some words that are keywords for this topic modeling task. For instance, for pricing might be inexpensive, cheap, or high, or increasing, or something like that. And if you seed the algorithm with these words, you obtain an algorithm that is called a semi-supervised. But basically, you start with an unsupervised way of doing this. So you define number of topics, you give the algorithm the text, and it's dividing it into sentences, assigning a topic, and then you have to model these topics. You have to say that topic number 1 of, okay, so because in this topic there are a lot of words that refer to pricing, this is probably connected with pricing. I will show you an example of that later on. Okay, so how can we use NLP for the business processes, for our applications? Basically, when we do applications, we do them for the customers, not for ourselves. Well, sometimes for ourselves, but it's not very often. So we have to pay attention to why we are using these techniques. So for instance, if you know now these techniques that I mentioned before, you can say, okay, I can make an information extraction. I have a long text, I can use summarization for that. I can use named entity recognition to find out which brands are mentioned in the text that are maybe important for me. You can make a lot of things using just these simple techniques, taking the whole text or the bunch of text or the bunch of reviews and analyzing them with the previously mentioned techniques. You can have something quite fancy, because we did that in PGS for one of the customers. The story was that the customers had an SAP system, and it's a B2B business. So they have the salesperson that went to the customers and spoke with them. Just discussed about different things, gathering rumors, gathering information from the market. For instance, that their competition is giving a lot of promotions and a lot of price things, price bonuses and these kind of things. And they had these noted just as a simple sentences. There were tens of thousands of them. And they wanted to analyze that. What we did in PGS is that we took all of these sentences, designed a pipeline using spicy library, so finding named entity recognition, measuring sentiment, finding the right words, defining all of these things that we need inside this pipeline. At the end of the day, we prepared for them a dashboard. And they had a dashboard reflecting to a so-called 4P marketing perspective, which is price, place, promotion, and product. This is just a marketing term, but basically it meant that we allowed them to switch to the price perspective, and they had a dashboard showing that, for instance, their competition X is raising prices, or there are a lot of promotion from their competitor Y, for instance. And they didn't have to read all of these reviews. They just looked at the dashboard, and it was the first time when they meet these sentences. They could, of course, read them, because there are some important things, some outliers. For instance, if you take this into consideration, that some people might mention your company or your customer's company, and most of these sentences are negative or have negative sentiment, then probably you have to read them and see what's inside. But this gives you a lot less work at the end of the day. Then we can do something like a product review analysis. You probably know that most of the e-commerce sites might have for different products hundreds of reviews. I don't know if anybody reads that. I suppose so, but this is not a very convenient way and not a very convenient job. Nobody wants to actually do it. So probably the best way would be to analyze them with the machine learning capabilities, with these libraries. So you can take all of these reviews, find the negative ones, or find some inconsistencies. For instance, suppose that you analyze 1,000 reviews of a given product, and for every review you have a text, but you also have a stars rating. So there probably might be some reviews that are negative in sentiment, but they have 5 stars. Why is that? Or some positive with 1 star. Or these kind of outliers that you probably have to analyze carefully. Or maybe you just take these reviews that are negative and say, what is mentioned there? What is the sentence about? So you can analyze that with named entity recognition pattern, or you can analyze this with another tokenization technique that can give you the keywords that are very often occurring in the texts that are negative in sentiment. So look how many possibilities do these techniques give to you. You don't have to worry about how this works under the hood. You just have to know the techniques. You have to know the business reason why you are doing that, and say, well, okay, in this case, I have to use the named entity recognition. I have to use the syntactic parsing to detect the relations between words. This is that simple. Okay, so let's check how to do it. First of all, you have a bunch of libraries and services that allow you to do it. For instance, there is, like I said before, Spacey library, which is working in a so-called pipeline manner. So it's analyzing the text in a pipe. After tokenization, then you have the lemmatization, then you have the part of speech tagging, and all of these things take place in a pipe. You have also GenSim, which is a library for topic modeling, quite sophisticated one. You have, of course, a scikit-learn, which is a basics for every machine learning developer. And you have these cloud services, so Google Cloud Natural Language API, Azure Cognitive Services, and Amazon Comprehend. You can use all of them. But I will show you now, if I can, an example. First of all, sorry for that. I will show you how to do it in a real code. This is just a sample of a Jupyter notebook. I'm always scared when I'm showing a live code, so this is not a live code. This is just a downloaded from Jupyter notebook. So first of all, what you can see here on the top of the screen is how we load the pipeline, the default pipeline for Spacie. There are a lot of default pipelines. You can build your own. You can always train something on top of the Spacie pipelines. Spacie is extendable. So for instance, I'm using two extensions that are available in the Spacie library. One is called Spacie Text Blob, which is used for sentiment analysis, and the other is Language Detector. And then you see that there is a text code. Europe is the best conference for developers. And in the next line, we have an example how to detect the nouns, or the noun chunks, in fact. Because there are not single words. You have a noun chunk called the best conference. So this is very important for you. Not conference itself, but this is in the context, in the conjunction with the words the best. Then you have something, because the pipeline takes the sentence, takes the text actually, and does all the things in a pipe and returns a so-called doc object. So every time I'm getting something out of the text, I'm using the doc object, as you might see. So whenever I started in 39 line, you have an NLP text. This means that Spacie took this sentence and pushes it through the pipeline. And at the end of the pipeline, I have all the information that I want. Because I've added before the Spacie text blob, which is responsible for sentiment analysis, then in the line 40, or in the block 40, I have the sentiment available for me. So the sentiment, as you can see, is 1, so it's totally positive. This is a subjective sentence. This is pretty obvious. And I have an explanation of why it's positive. Then I have something about the language that is detected, and later on I have, sorry for that, I have, I present the table, which is an output of a part of speech tagging and also a morphological analysis. As you might see, the lemmas are mentioned, so the lemmatization takes place before the part of speech tagging, because this is what Spacie does. And you have all the informations below, just by running a single line of code, nothing more. You don't have to know anything more than that. And there are some super fancy libraries from Spacie which allow you to display or highlight the entities found, and highlight also, or present also the dependencies in the sentence. But this is just for a single sentence. Okay, so this is not very useful in the real life. But what you have to understand is that because Spacie works on sentences or on documents, it might be a longer text, of course, but it is not always useful. If it's a longer text, the first thing that Spacie does is divides it into sentences and then makes an analysis on top of every sentence. But you have probably a bunch of information, like a file with 100,000 sentences. Then you have to push every sentence through the pipe. And this might be done like in this document. I'm not left-handed, so it might be difficult for me to navigate. This is the list of restaurant reviews on top. They're presented. So you have a review, and the rating which is limited to the values 1 or 0. This is a data set taken from Kaggle, actually, one of the contests from Kaggle. And this is just a picture showing how Spacy works, and as I said, the text is on the left. Then you have the text pushed through the pipeline, and at the end of the pipeline you have a doc which provides you all the informations. So first of all, just like before, I'm loading the Spacy pipeline. Then there is a couple of samples because I just took one of the sentences to show you the non-chunks. I always showed you here the sentiment of this sentence. As you might see, this is a single sentence, but you have the object available which is called sense, which gives you the sentences mentioned in the text. So this is just a so-called, let's say, proof that what Spacy is doing is dividing the long text into sentences. And of course, the tokens found, I just showed that before. And now I'm pushing everything through the pipeline. So forgive me the quality of Python code. I'm not a Python developer, so I'm writing everything that it works, but does not look very brilliant at the first glance. So you can see that it took something like 8 seconds to analyze 1,000 reviews. This is a data set that consists of 1,000 reviews. And what I'm doing, I'm just writing into a data frame that this given text has a language, what language is used in the given sentence or a given review, what is the polarity, what entities have been found, what tokens, so words that I want to find, because we can limit, we can say, I want to find tokens, but only these that are nouns, adverbs, and adjectives. Nothing more is interesting for us. This just depends on the purpose, why you are doing this pipeline. And the last two columns are liked. This is the column provided in the reviews list. And the sentiment is just detected from polarity, because we can assume that if the polarity is over 0.05, it's positive. If it's less than minus 0.05, it's negative. And between those two values, it's neutral. And what I can do, what I can provide to the customer in a simple way, how many sentences or how many reviews are negative, how many neutral, how many positive. What I can do also is I can do something like that. This is pretty nice because it shows you what's the correlation between the liked or not liked, so something that the customers or the reviewers marked as they like or not, or with the sentiment detected by the Spacy library, by our pipeline. So as you might see, the correlation, there is a correlation, but not very high. The thing is that there are a lot of sentences that are considered, that are not liked, but are considered positive on the left-hand side. Because to have a very good division between these two data sets, between these two sets of data, it should be that the left blue dots should be below 0 and the orange dots should be above 0. But then you have an information. Maybe I have to read these sentences that are considered negative, but still are liked, and the other way around. So this is an example of a data set that consists the sentences that are liked, but the negative sentiment was detected. For instance, you have the word, this is like the sentence number 4, extremely tasty. I don't know why Spacy said that this is a negative, but it said so. So we have to be careful here. Or the sentence, you have this sentence here, number 324, it's you won't be disappointed. The sentiment detected was minus 0.75, and I can tell you that Comprehend said that the sentiment is plus 0.99. So this is completely different. This has completely different interpretation. Okay. It depends. The question was, what's the point in adding these things if it has so low accuracy, as I understand, if I understand well. The thing is why you are using it, because if you want to have a quick analysis with spaCy, it's very quick, it's inexpensive because actually it's for free. So you can build a simple pipeline that analyzes your sentences, and it might be useful at some point. But if you want to use something more sophisticated like Amazon Comprehend, you have to be careful because you will pay for that. And it works a little bit slower, well, much slower than spaCy. So probably this will lead you to a situation where the first shot will be on spaCy, but then you see, well, there are a lot of outliers. This is not relevant for my needs. I will use Comprehend. I prefer to pay and have better results. Basically, sentiment analysis, I have to be clear, sentiment analysis is not a part of spaCy. Sentiment analysis or spaCy text blob is an extension to spaCy written by someone else. You can write your own. Because this is pushed through the pipeline, you can even build your own extension to spaCy, which uses Comprehend to analyze your sentiment. I'm just showing you the difference. There is another library that I have tested, and it's much better in recognizing sentiment, which is Vader. This is a library that that is only used for sentiment. It's just these kind of things. And the correlation here is much better. And I can show you the same, I do the same things as before. And the correlation, as you might see, is much better. It's still, it's not very good, but this correlation, this problem with correlation might not mean that the library is wrong. It might mean that people who said something negative about the restaurant give their likes. So you have to be careful and analyze that. You cannot avoid a human in the loop. It's no way to do it. It just gives you a quick information about what is analyzed, but it will not replace the manual reading of some of the reviews later on. And the last thing which I wanted to show you is the topic modeling. This is quite nice thing. I'm using also the spaCy model to remove some of the words from the topic modeling. Because how topic modeling actually works? It uses two terms which are the basic terms for text analysis. One is a dictionary, and the second one is corpus. Dictionary is a list of words used in the sentences which are identified by a given ID. So this is just a list of pairs ID word, nothing more. But dictionary will consist only of these words that you want to have it in the dictionary. You are not interested probably in the determiners. They don't give you any information. You're not interested in punctuation. You're probably not interested in prepositions, in different types of words that don't give you enough information or don't impact in any way the topics that you will want to detect. So what I'm doing is just I'm loading the NLP library and removing all the things that are not interesting for me. So pronouns, punctuation, determiners, and these kind of words. And then I'm creating the dictionary out of every other word. But the dictionary is created for all the sentences in the dataset. So there is one dictionary for all of the 1,000 sentences in the dataset. Then I'm creating a corpus. Corpus is telling us how many times the given words in a dictionary are used in the given sentence. This is obvious that it implies or can impact the way how we do the topic division between the sentences. Because if any word is used more than once, like for instance, word inexpensive is used two times in a given review, it might mean that this sentence is very much about pricing. So in a first shot, I'm building the tokens library. This is just a simple way of using the NLP pipeline, so the spaCy pipeline, which is taking all the reviews, removing all the not interesting tokens, and creating a list of sentences. There is a data set on the below where you have the ID of a sentence and the tokens found in these sentences. They are usually in the root form, so the lemmatization has to be done before. That's why spaCy is essential here. And now I'm creating dictionary and corpus. So there is an example there. Dictionary is an ID word mapping. For instance, 0 means love, 1 means place, and so on. And corpus contains the information how many times the given word is used in a given sentence. And then we have to do some magic. I don't want to explain this, what is a coherence measure, but the thing is, remember that we don't know how many topics do we have, because topics do not reflect the number of topics that we want to use at the end of the day. If we have 4 topics like quality of service, quality of food, cleanliness, and price, this does not mean that we want to create 4 topics out of this text initially, because they will be mixed. It's not a good scenario. The thing is that the algorithm does not know how many topics and what they are about. So there is something that we do before. We are creating the models, and every model is testing different numbers of topics. And then we use so-called a coherence measure to show which number of topics is the best one. As you might see, if the lower the chart is, the best the number of topics is, the better the number of topics is. So we can say that, let's say, 10 topics or 16 topics might be the best choice for us. Maybe 16 is too much, but what we do then is just we do something like that. Just a single line of code. We have an LDA multi-core model builder. LDA is an algorithm called latent Dirichlet allocation. LDA is not the only algorithm for building topics and making topic modeling. There are lots of them, but LDA is by far the most popular one, I can say. So we give the library a corpus, our dictionary, the proposed number of topics, and it just does its job, nothing more. And we can display these topics. And as you can see, these topics are in fact saying that these particular words, if they are occurring in a sentence, it probably means that this sentence belongs to this topic. And then you have also a weight assigned to a given topic. So what it did, in fact, it's just divided all of these sentences into virtual topics, gathered the tokens, and said, well, probably if you have a word service, it's occurring in 6% of the topics that I assigned to, in the 6% of the sentences that I assigned to topic 1. This might be interpreted like that. So the thing is, there is a nice visualization of that. This gives you a proper division between topics. Whenever you say, I want to analyze the topic 1, and I can say that the topic 1 is using the terms, so the most frequent terms in these reviews are food, good, friendly, eat, service, stuff, try, delicious. So I can pick a couple of them and say, probably topic 1 means the quality of food, because food is mentioned everywhere, and there are some other keywords about the food. What gives us the topic 6? This is just a distance, mathematical measure. I will not go into details, but the thing is that in this topic we have the words good, restaurant, buffet, selection, dish. So this is probably mentioning something about the restaurant as a whole, not the quality of service, but how rich the menu of this restaurant is, on these kind of things. So you have to carefully interpret what is what the given topic applies to. And then, if you have this model prepared before with a single line of code, you can say, well, I have a new document. For us, the document is just a list of, or a diction, a list of words. So these tokens that I have prepared before. As you remember, I've done one thing above. I took all the sentences and got all the topic, or the words, or the tokens that are important for me. So nouns, adjectives, these kind of words. And then I'm creating, to detect the topic, I'm creating a new document. So this is a new review, and I want to assign it to a given topic. So I'm creating a new document, which is a list of tokens. And with these 3 lines, or actually 2 lines of code, I'm detecting the topic, and I'm seeing that the most probably this is the topic number 2, because it has 55% of confidence that this sentence belongs to this topic. And because previously I analyzed all of those topics and said topic 1 and topic 3 is about pricing, I can say this sentence is about pricing. Actually, this sentence is completely not about pricing. It's about probably quality of food. And one thing at the end, I can show you how it looks in Amazon Comprehend. You can use it as an API. This is again the same sentence. Code Europe is the best conference in Poland. And you can see that it provides us with the same information. For instance, here I have the syntax. So what this part of speech it is, the sentiment analysis. You can also detect the entities. So basically, it's more or less the same. It's a little bit more rigid, so you don't have you cannot do everything there. You can build your models, of course, but this is complex. However, it's very good in quality. So you have to consider what you want to do. In Amazon Comprehend, basically, you can load your sentences in batches. This is much cheaper, but still it costs, and still it takes time, because every call to their API actually detects only one thing. Like, for instance, sentiment. It can also make a topic modeling, these kind of things, but it's always a single shot for a given bunch of texts. Okay, so just some key takeaways and some wrap-up. First of all, you have to be aware that every company, you probably know that every company is gathering textual information. And they usually have problems with analyzing this textual information because they don't want to read all of them. But you can provide them with a quite simple set of tools. You can build on top of these simple NLP techniques a tool that can help them to analyze this text. And what is more, you can provide them, you don't have to understand what's under the hood. You have to, however, understand these techniques, these concepts, these terms to deliver a quality software in terms of NLP text analysis. Thank you very much. If you have any questions, just please.
Thank you for the presentation. I wonder how it does look like regarding support for other languages than English, because, for example, we have a restaurant in Poland, we have Polish reviews.
Okay, I didn't show you one thing because I didn't have time. I have 1 minute, sorry, but I will do that quickly. Spacie allows you to load different languages because you can build your own models, your own dictionaries. And this is just an example of Polish language, which is quite difficult. But as you can see, the lemmatization works pretty well. And the analysis also gives you a lot of information. This might be used in the Polish language class in the grant school. So you have most of the most popular languages are used, you are able to use within Spacie or within Amazon Comprehend, within cognitive services, different things.
Well, thank you so much. I have actually a lot of questions, but maybe just one or two. Okay, mostly we heard here about text and text analysis, but natural language processing is processing of language, but of course language is much, much more than just a text. For example, I'm now speaking and this is just my voice and I can manipulate by my voice and other things and I can say just with one word a lot of meanings. So how it's about it in machine learning and where is it comparing to the text analysis?
Okay, I'm not sure if everyone heard the question, but the thing is about other things than just simple text analysis. I just mentioned that in the beginning of the presentation that NLP is a huge world of different techniques and different tools. So there are also tools that, for instance, just responding to your question about, for instance, word disambiguation. So the meaning, different meaning of words, because you might have a word that means different things in different contexts. So there are techniques around that. They are not that simple. They are usually based on dictionaries as well. But text analysis is just a small part, but very, very useful. So if you want to be, if you're interested in NLP as a whole, well, probably this is a lot of things that you have to know exactly, like the techniques connected with speech to text or text to speech, chatbots, or different kind of things. Okay. Thank you very much, because I think that my time just went by. And if you have any other questions, I'll be later on at PGS stand below. So you probably, my friend in an orange t-shirt is there. So just look for orange t-shirts. I'll be there in a couple of minutes. Thank you very much.